Okay, so topic 7, part 2, we're going to talk about the concept parallel and perpendicular lines. We determine if something is parallel or perpendicular based off their slopes. So if the slopes are the same, then it's parallel, but if the slopes are opposite reciprocals, then they are perpendicular. So we know that reciprocals means to flip the fraction. The reciprocals means to flip the fraction. Opposite means we change the sign. So if it's positive, then we're going to change it to negative and then flip the fraction, and vice versa. When we look at the graphs of parallel and perpendicular lines, parallel are two lines that, are parallel to each other. And then perpendicular are two lines that cross at a 90-degree angle. There are two shorthands you may see for parallel and perpendicular. So instead of writing parallel every time, the shorthand for parallel is just two parallel lines next to each other. So what I wrote in purple up here. And for perpendicular, it's an upside down T. So you'll see those, do I put them in the notes that way? No, not on these notes. These notes I write out the words, but you will see that later on, so I'm not just rewriting parallel, perpendicular. Okay. So on these examples, it wants us to find the slopes and then determine if it's parallel, perpendicular, or neither. So looking at number 25, these lines are both in what form?
Slope-intercept.
Slope-intercept. So that means we can easily find the slope because we know the slope is going to be in front of what? X. So looking at the first one, the number in front of X is -2. So we have our slope here is -2. And then same with that second equation, we also have -2 in front of the X. So this slope is -2. Since our slopes are the same, what type of line is it? Parallel. Good. Okay. Same for 26. What form are these lines in?
Slope-intercept.
Slope-intercept. Remember, we've only talked about two, slope-intercept and standard. So again, since it's in slope-intercept form, what's the slope of the first one? Good, 3. What about the second one? 2. Okay. So we know they're not the same, so that crosses out the parallel. They're not going to be parallel. But what we need to do to one of the slopes is take the opposite reciprocal and see if we get 2. So let's assume that 3 can be written as 3/1. If I was to flip the fraction and change the sign, what would that slope be?
-1/3.
-1/3. Does that match 2? Or I should say is, no, that's right. Does that match 2? -3 and 2? Nope, so that means this is neither. So it's neither parallel nor perpendicular. Because once you take that opposite reciprocal, that new slope should match the second slope that we find.
How would that look on a graph?
It would look like two lines that never cross at a point.
Okay.
So it could be like a
Like they get
let's
real
say,
close but never touch.
yeah, something like that. They keep going like this, but you know, the slopes are a little off, so they're not parallel. And it doesn't ever cross at a 90-degree angle, so it's not perpendicular. Yes?
Would we ever have graphs that cross but don't make a 90-degree angle?
That cross and don't make a 90-degree angle. Yes, they could cross and not make a 90-degree angle, but we wouldn't consider that perpendicular because it would have to be a 90-degree angle. And we'll talk about those type of equations when we move on to system of equations, and I believe that's the first topic after test 1. But yes, good point. Okay, what form are the lines on 27? They're in which form? Slope-intercepts. That means our slope in the first equation is what? 1/2. What about the second equation? Good. So right away we know they're not parallel because they're not the same. So I'm going to take that first slope and take the opposite reciprocal. So the opposite of positive would be negative, and then the reciprocal of 1/2 becomes 2/1, or we could just say -2. Does this number match our second slope? Yes, so that means these are perpendicular. So if we take the opposite reciprocal and then that number matches our second slope, we say those lines are perpendicular. Okay. So the first 3 were pretty easy because they already had them in that slope-intercept form. Now on 28, our first step is going to turn each equation into slope-intercept form before we determine if they are parallel or perpendicular. So for the first equation, we have that 3x plus 4y equals 2. We need to get y by itself, so what would be our first step? Good, move the 3x over. So we have 4y is equal to negative 3x plus 2. And then what would be our last step? Divide every term by 4. So for our first equation, we have y is equal to negative 3/4 x. So remember that number has to come away from that x, has to be in front of it, plus 1/2 because 2/4 reduces to 1/2. This is our first equation. Okay, same with our second equation. We have 8x minus 6y is equal to 5. What's our first step? Subtract 8x. So I have negative 6y is equal to negative 8x plus 5. Next step. Divide every term by negative 6 because we want y to be by itself. So I have y is equal to negative 8 over negative 6, which means the negatives cancel to a positive. But can we reduce 8 over 6?
Yes.
To what number?
4/3.
Good, 4/3. Minus that 5 over 6 because we can't simplify 5 over negative 6 any further. Okay. So that is the second equation.
Switching the symbol from negative to positive on that division
Mm-hmm.
threw me off on one of the homeworks. Because I use an app that helps me see if I got the right answer.
Mm-hmm.
And that threw me off.
So this part right here where we went from here to here?
The first part, the negative 8 divided by negative 6 on the answer, I would have kept that 4/3 as a negative. That threw me off.
Oh, okay. Just if we have a negative divided by a negative, it turns into a positive.
Yeah, okay.
Same with a negative times a negative, that's also a positive. Okay. So, looking at our first equation that I have highlighted in pink, what is the slope?
-3/4.
-3/4. And the equation in green? Good, 4/3. Okay, so they're not the same, so that means they're not parallel. So now let's check to see if we take the opposite reciprocal of that first slope and if we get the second slope. So opposite of negative would be positive. And what's the reciprocal of 3/4? 4/3. Since these match, that means we have a perpendicular line. Okay, so this one we had extra steps because we had to turn it into we had it in standard form and we had to turn it into y-intercept form. So we might have problems like 29, where 29, one of them is already in the correct form, but one of them is not. So which one is the equation we're going to have to change? The top one. Okay. So we have 2x equals y minus 10. We got to get y by itself, but notice the y is now on the other side. So what are we going to do to get y by itself? Add 10. So we have 2x plus 10 is equal to y. Okay. I want to write this in the correct form with y in the front. So I'm just going to switch y equals 2x plus 10. Okay, it's the same thing, it just switched the sides of the two components. Okay. Now that it's in slope-intercept form, what is the slope of this equation? 2 or 2x? 2. Remember, if you put 2x, that's wrong. Okay, our slope does not contain a variable, it's only a number. Okay, and then what about the other equation? Good, -2. So the slope for this one was -2. Okay, so right off the bat, what do you think it is?
Parallel. Right or not?
So it's not parallel because one's negative and one's positive. Okay,
It's neither, right?
and it's correct. So it's not perpendicular because even though the signs changed, it didn't take the reciprocal of 2, which would have been 1/2.
It has to have both.
Has to have both. Yep.
I missed that part.
So this means this is neither. Has to be both opposite and the reciprocal. Okay. Okay, now on number 30, we need to only change one equation. Which one, the top or the bottom? The top, because the bottom is already solved for y, it's just reversed. So for that one, we could just switch the y to the front. But starting with that top equation, 7y plus 1 equals 7x, what do we have to do to get y by itself? Good, subtract 1. So we have 7y is equal to 7x minus 1. And then last step, divide by 7, every term. So I have y is equal to, what number is going to be in front of x? It's just x, right? Because we don't write 1x. Minus 1/7. Okay, so that's our new top equation. And then this equation here, we could just swap it as y equals x plus 5 to put y on the correct side. Okay. So now that we've done that, what is the slope of the equation I wrote in red? 1. What about the other slope? 1. So what type of line is it? Parallel. Because both of these slopes are the same. Okay. you're never going to have a problem where you're going to be solving for these type of examples, okay? This is just to show you the difference between parallel, perpendicular, and neither. The problems you're going to see on an exam are the next problems that we're doing. So we learned about standard form, we learned about slope-intercept form, and now we're going to learn about point-slope form. And this is the last form for linear equations. Okay, so it says you can find a linear equation if you are given an equation, given a point, and given if that equation is either parallel or perpendicular to the first equation. So the important part from here is that point-slope form. Point-slope form we write as y minus y1 is equal to m parentheses x minus x1. Okay, so that's the formula we're going to be using for the rest of these problems. Okay. So what we're going to do is we're going to find that new equation and then we're going to graph it. So for number 31, it says through negative 2, 2, parallel to y is equal to negative x minus 5. So the point that they give us, that is our x1, y1. Always. And then right here, since it says parallel, that means we first have to find the slope of that equation given and then find the parallel slope to that. So what would be the slope of that y equals negative x minus 1? 1 or negative 1? Negative 1 because of that negative. So right here, we say that slope is negative 1. Excuse me. Since it wants us to find a parallel, that means our new slope, which I'm going to write as slope parallel with those symbols, is still negative 1. So the information we're using here is this slope and this point. And we're going to plug it into the formula. Y minus y1 is equal to m x minus x1. So in this case, y and x are the variables. Okay, so we're not plugging in anything for y and we're not plugging in anything for x. The y1 and the x1 is our point, so we're going to plug in those numbers. And our m in this case is always that new slope you find. Okay. So plugging everything in, I have y minus 2, so that's my y1, is equal to negative 1, that's my new slope, x minus x1. Since my x1 is also negative, I'm keeping it in parentheses. Okay. Now I just simplify. So remembering PEMDAS, I do everything in the parentheses first. So minus a negative turns into plus a positive. So I have y minus 2 is equal to negative 1 x plus 2. What would be my next step to simplify? Yep, multiply, but what's the proper name? Distribute. So I have y minus 2 is equal to negative x minus 2. And then last step, add 2, which leaves me with y is equal to negative x. And in this case, I'm just going to write that plus 0 since we are graphing, so we could see that the y-intercept in this equation is 0. Okay. So we have our original equation up here and our new equation down here. So we're going to graph both of those equations. So in our original equation, what was our y-intercept?
-5.
-5. So I'm going to plot that on the graph. Okay. And we said our slope was -1. So how does that look when we're doing rise over run? How does -1 look if we're doing the rise over run?
For the first one, -5.
The point is supposed to be a negative.
Oh, yes.
Oh yeah, you put it on positive.
Thank you.
I see what you're saying. Good.
My bad. Okay. So now I have to figure out how I'm doing the slope of -1. But I'm using that rise over run method. So am I going to go up 1 or down 1? Down 1. Okay. And then since this is a whole number and it's not a fraction, I'm going to go in the positive direction 1 because -1 over 1 is the same as -1. So I'm going to go over 1. That's my dew point. So this is my original one. Okay. On my new one, what is the y-intercept? 0. And my slope is the same. It's still -1. So I'm going to go down 1, right 1. And then that is my new line. And notice how these lines are parallel, just like it says in the problem.
So I think I confused myself, but pretty much you're just graphing the original and the new formula, correct?
Yes. Yes, the new one and the old one. And again, that is just showing you a visual. And just showing you the visual. On an exam, if it's just asking you to solve and there's not a graph on the test, then you're not going to need to graph it. I'll provide the graph on the paper. Okay, let's look at number 32. Okay, number 32, it gives us a point. It gives us our original equation. And again, it's telling us to have something that is parallel, so same slope. So writing our formula, we have y minus y1 is equal to mx minus x1. So plugging everything in, we have y minus y1, because remember this point is x1, y1. So y minus 0 is equal to, what would be our slope since it's going to be parallel? Good, that -3 over 2. Okay. So then I have, sorry, I should not write that in red. So then I have -3 over 2, parentheses, x minus x1. Since, again, x1 is a negative, I'm placing that in its own parentheses so I don't get it confused. Sorry, one moment. Okay, so then simplifying this, we got to do the parentheses first. So minus a negative turns into plus a positive. So I have y equals. Why did I drop that -0? Yeah, it's 0. It doesn't matter. So I don't have to like add 0 to the other side. So right now I just have y equals -3 over 2, x plus 2. I just simplified those parentheses. What's going to be my last step here? Good, distribute. So I'm going to have y is equal to -3 over 2x minus, because I have a negative and a positive, minus, I'm just going to go ahead and write this step out. So 3 over 2 times 2 over 1.
It's 6 over 2, which is 3 over 1.
Correct. So we would multiply tops and bottoms, and it would become 6 over 2, which reduces to 3. So this is y is equal to negative 3 over 2x minus 3.
How did you get that again?
Yes, let me go back. So from here, I multiply the top. So this right here gives me 6. And then I multiply the bottoms. This gives me 2. 6 divided by 2 gives me 3. And then since that negative is right here, I just brought that negative down. So my original and my new one. So then I'm going to take those equations and I'm going to graph them. So in my original equation, what was my y-intercept? Negative 2. And my slope for both of them is what? Negative 3 over 2. And if I'm thinking in rise over run, what is that telling me to do?
Left 3.
Down 3 over 2.
Good, down 3, because rise is first, so it's either going to go up or down. So down 3, right 2. And that is my first. Okay, what is my y-intercept in my new equation? Negative 3. And again, I'm going down 3, right 2, because it had the same slope. So now I'm connecting those two blue points. And notice that these graphs are parallel, but they are very close to each other. And that was because their y-intercepts were like 1 away. So one was negative 2, one was negative 3.
So if we get a question on this and it doesn't have a graph and it just wants us to solve it, how exactly is it going to word it? Is it just going to ask for the slope intercepts?
It is going to look exactly like this, but I will not put a picture of a graph.
You just want the original and the new?
Yep.
Okay.
Yeah, on the exams, if I don't give you that grid for the graph, you're not graphing. I'm not going to have you draw the graph.
How many questions will be there for this one?
No more than 20, I know that. Just because you guys only have an hour and 15 minutes, so no more than 20. Okay. Okay. So for number 33, this parallel was supposed to say perpendicular. That was a typo. So for 33, it should have said perpendicular. Okay, so labeling my points, I have my x1, y1, and then I have to find my new slope based on the slope that they gave us. So the slope that they gave us originally is what? Negative 4 over 3. And since it wants us to find the perpendicular slope, notice how I wrote that as m and then the perpendicular symbol. I have to do the opposite reciprocal. So what would be the opposite reciprocal of negative 4/3?
3 over 4?
3 over 4.
Because you switched the signs too.
Correct.
Okay.
Correct. So plugging this into my formula, I get y minus 4 is equal to 3 over 4 x minus a negative 3. Everyone see where I got those numbers? Okay, my first step would be to simplify those parentheses. So x minus a negative is plus a positive. So I have y minus 4 is equal to 3 over 4 x plus 3. And then I have to do what?
Distribute.
Distribute. So I have y minus 4 is equal to 3 over 4x plus, what's 3/4 times 3?
9 over 4.
9 over 4. Because remember that 3 can be written as 3 over 1. And we multiply the tops, then multiply the bottoms. And then last step, we would add 4 to both sides. And we would get y is equal to 3/4 x plus, notice that we have pretty much two fractions we're adding here. 9 over 4 and 4 over 1. So that means we would have to get a common denominator. In that case, that would be 4. So that 4 over 1 is going to become 16 over 4 because I'm multiplying the top and bottom by that common denominator. So now I have 9 plus 16, which is,
It's just 4. I'm sorry, I got ahead of myself.
no, we're adding the numerators here. 9 plus
I know, I got
16.
ahead of myself.
Okay. $25. Which means this is the 25 over 4. If we add 9 plus 16, then we get 25, and it's still over 4, so we are putting that in our equation.
How did you get 16?
So when I was adding the 4 over 1, we had to get a common denominator of 4, so I multiplied the top and bottom by 4. So that's how I got 16 over 4.
Okay, that makes sense.
Instead of graphing the last of these problems, we're going to be turning them into standard form. So that needs more practice than the graphing. So right here in our work, we have this equation here. That is our point slope form. So remember, there are 3 forms. The form that we just found is what form? Slope intercept form. And then the last one I want to find is standard form. So you will have problems like this on the exam. Yes? So the 16 came from us doing 9 over 4 plus 4 over 1. So that 4 over 1, we had to get a common denominator of 4. So we would have to multiply the top and the bottom by 4. And that's how I got 9 over 4 plus 16 over 4. When we added the 4 over from this side, we added it to this side, but since we were adding it to a fraction, we have to put it over 1. Okay, good question. Okay, so now we have this y equals 3/4 x plus 25 over 4. How would we turn this into standard form? Good, we're going to have the x on the same side as the y. But before I do that, I want to get rid of the fractions. So what should I multiply everything by? 4, because when I multiply everything by 4, it's going to cancel out the 4's that are in the denominator. So that leaves me with 4y is equal to 3x plus 25. Does everyone see how I got that?
Multiplying the greatest common denominator, correct?
Correct. The common denominator. And in this case, they were both the same. That's why 4. Now I want my x's on the same side, so I'm going to subtract my x's over. And remember, in standard form, what comes first, x or y? X. So I have negative 3x plus 4y is equal to 25. This is my answer in standard form. And again, we're not doing the graph. We're just practicing the forms.
I'm very confused. What's the formula for standard form again?
Standard form formula is the ax plus by equals c.
That's right.
So those three forms are the only forms we need to figure out.
Correct. Those are the only three forms for linear equations. Okay. Like I said, I'm just changing up the notes because it's more important for us to do the three forms than it is to graph. Okay. So looking at 34, we're going to do the same. We're going to put it in point slope form, slope intercept form, and then standard form. Okay, so we have our x1, y1 from that -3 and 1. We want our slope to be perpendicular to the equation y is equal to 3 over 5x plus 2. So in this case, what is the slope of this equation? 3 over 5. But since we want it to be perpendicular, what would be our new slope? -5 over 3. Change the sign, flip the fraction. So then plugging it in to our formula, we get y minus 1 is equal to -5 over 3, x minus a -3. Anytime I plug in a negative number, I put it in parentheses. Then I'm going to simplify the parentheses and then distribute that -5 over 3. So I get y minus 1 is equal to -5 over 3 minus, what's -5 over 3 times 3? Close, -15 over 3, which becomes, good, that -5. Okay? Or think of it like this. -5 over 3 has a 3 in the denominator. So for multiplying by that same number in the denominator, they cancel out. So that's how we're just left with that -5 here. Oh, yes, thank you for getting the x here. And then our last step is to add the 1 to both sides, and we get y is equal to -5 thirds x minus 4. So we already have two forms here. We have this first form, and that's just when we plugged in all our numbers into the formula. And that is our point slope form. I'm just going to draw an arrow though. Point slope form. And then once we solved everything that we plugged into our formula, we got our slope intercept form. And now our last step is to put it in what form? Standard form. So in this case, again, we still want to get rid of that fraction. So we're going to multiply everything in that equation by what? 3. Because that's the only denominator there is that 3. So everything is going to get multiplied by 3. So we have 3y is equal to, what's -5 over 3 times 3? -5, because those 3's cancel, so -5x, and -4 times 3, -12. For standard form, we want x and y's on the same side, but x's always come first. So when I add the 5x over, is it going to go in the front or in the back? The front. So we have 5x plus 3y is equal to -12. And this is in standard form. And just remember, each form is good for one thing. So for example, the point slope intercept form is good to find a linear equation if you're only given the point and the slope. The point slope form. Bless you. the slope-intercept form is good if you're only given the slope and the intercept. And then standard form is good if you have to find the x and y intercept. So they all have a purpose. Okay.
Sorry, what is the purpose of
Slope-intercept form is if you are given the slope and the intercept, it's best to use slope-intercept form. Just think of just think of their names. The only one that doesn't have it in their name is standard form, and standard form is good for x and y intercepts. Okay, so again, we're not going to graph on these. We're just going to put it in the three forms. So I have x1, y1. It wants me to find a perpendicular slope. So what's my original slope? Good, so what would my perpendicular slope be? Perfect, 4/3. Writing my formula and plugging everything in. So I got y minus 5 is equal to 4/3 x minus 3. This right here is in what form? Point slope form. Solving point slope form, we're going to distribute that 4/3, and we get y minus 5 is equal to 4/3 x minus what number?
3?
Not 3.
4.
4. Why 4?
Multiply 4 by 3 and get 12 over 3.
Correct. 4/3 multiplied by 3/1 gives us 12/3, which is 4. Or you can just remember that since we are multiplying by the same number that's in the denominator, they cancel. And then last step, adding the 5. We get y equals 4/3 x plus 1. This is in what form? Slope-intercept. And since we have a fraction here, before we turn it into standard form, what are we going to multiply everything by? 3. Why 3? Good, it's the only denominator there. So I have 3y is equal to, what's 4/3 x times 3? Good, so 4x plus 3. I need to move my x's over, so what is my equation going to look like?
Negative 4x plus 3y.
Equals, good, and this is in what form? Standard. Again, we're skipping the graphing part. Okay. So we're going to do the same thing for 36. And notice I have more problems for perpendicular than parallel because I feel like that one's the harder one to remembering to take the opposite reciprocal. Okay, so on 36.
I'm sorry to pull you back, Matt.
Yeah, yeah.
I missed where you got that -4 from.
At this point?
Yes, from that point. Yeah, right after you did the point slope and you distributed, I lost where you got that -4.
Okay, so when I did 4/3 times -3, when I distributed that 4/3,
Okay.
the 3's cancel. So these cancel, and I'm left with 4 times -1, which is -4. Or another way you could look at this is 4/3 times -3/1. Turn it into a fraction. So then if you multiply the tops, you get,
-12/3.
which reduces to,
4, yeah. 'cause of
Negative
the
4.
division. Okay.
Yeah.
I
Mhm.
got it now.
Mhm.
Thank you.
Mhm. Okay. So x1, y1, it wants us to find perpendicular. So what's our original slope? -2. What would be the perpendicular, opposite reciprocal? Good, 1/2. Because it went from negative to positive, and 2 can be written as 2 over 1, which if you flip it, is 1 over 2. So we have our formula, y minus y1 is equal to mx minus x1. Plugging everything in, we get y minus a -3. Since my y1's negative, I put it in parentheses, is equal to our new slope, which is 1/2 x minus x1, which is 4. This right here is my point slope form. Okay. When I simplify point slope form, that gives me my next form. So what I'm going to do first is I'm going to do that minus -3 and make it a plus a positive. And then distribute that 1/2. So I have y plus 3 is equal to 1/2 x. And then what's 1/2 times -4? Positive or -2? -2. Good. Then I just need to subtract the 3. And I get y is equal to 1/2 x minus 5.
So if I don't put two minuses for the point slope form and I just, just put plus, would that be considered?
Yeah, that would still be point slope form. Yep, if you simplified this step first, that's fine. Okay, so then we just found slope intercept form. And then before I turn it into standard, I got to get rid of the fractions. So what am I multiplying the entire equation by? 2. Why 2? It's the only denominator there. So distributing that 2 in, I get 2 times y, which is 2y. What's 1/2 times 2? 1, but do I need to write a 1 in front of the x? No, so it is just x. And then -5 times 2, -10. I need to move my x to the other side, so what is my equation going to look like?
Negative x plus 2y equals -10.
Correct, because remember, my x comes first always. And that is standard form.